Alright, there's the bell work. And since the bell rang, hopefully you guys have all four of those done. So there's our answers. 1n equals negative 17, 2p equals negative 15, 4c equals negative 6, and 5b equals 7 on those. That would make all those true statements if you were to replace the letters with those numbers. So that brings us to our objective. I can solve multi-step equations. Take a minute and write this down. Now we did go over solving two-step equations last time, but when it says multi-step, usually it means more than two steps. Okay, so sometimes we're looking at three principles of equality. Sometimes it also includes distribution and combining like terms, which is what we went over in lesson 2 of this unit. Yeah, before we look at those principles of equality, remember that a solution is really asking, or when it says solve for x, it's really asking what value of x makes the equation a true statement. So on the worksheet, it's going to say something like check your work or something like that, which is what we're going to do on these. Okay, we have to make sure that the original equation is true when we replace the x value we found into the original equation. All right, just replacing the x with numbers, which is what we did in the first section of this unit. Right? Wait, no. Here's the last unit, but it's an evaluating expression. So there's our principles of equality. But again, that's just all four of these, all four basic operations of math. It's just saying whatever you do to one side, you got to do it to the other side, whether it's addition, subtraction, multiplication, or division. All right. And yeah, we do show this a little differently. Right? We usually show it like this. Right? Remember that? So you'd say, well, add c to both sides, something like this. So we're going to be solving all of these, and we'll show the solving action, just the principles of equality, and then we will also verify our solution, which we should always do. So number one, the first thing we should notice on this is it looks different than the problems we've been doing. And remember, just like I talked about in the objective, is when it says multi-step, sometimes it's talking about distribution and combining like terms. And I do see like terms right here with the 4x's and the 3x's. When I combine those, it's going to give me positive 7x's. It also has a negative 1 term here, which we dropped. And then we're going to drop the 6 here also. Okay, so this simplifies into 7x minus 1 equals 6. Now it is a two-step equation. I got to isolate the x's by getting rid of that negative 1, zeroing it out. So I'm going to add 1. But again, if I do it to one side, I got to do it the other side. That's going to zero that out. We're going to drop the 7x, which now equals 6 plus 1, which is 7. And then divide both sides by the coefficient to make it a 1x. So 1x now equals 1. Let's show the work on this one for checking, even though you could do it in the calculator, right? So it used to be 4x plus 3x minus 1 equals 6. But we just solved and found that x equals 1, so let's replace all the x's with 1 and just see if it's a true statement, all right? So there's the 1. I put a question mark over the equal sign because I don't know if it's equal, but let's find out. All right, but I do know that it should equal 6. So 4 times 1 is 4, 3 times 1 is 3, 4 plus 3 minus 1. That's 7 minus 1, which is 6. That's true. So since that does come out as a true statement, now I know that my answer is correct. So here's number 2, 10 equals negative x plus 3x plus 4. And we see that this looks a little different than what we saw in the last lesson, particularly the x's, right? And we should ask ourselves, what is the coefficient of that negative x? And hopefully we know by now that it's a negative 1 right there, right? It's a phantom 1, so whether you want to show it or not is up to you. But at this point, we're kind of looking for any distribution, and yeah, there's none. But there is combining like terms, okay, which is what we talked about in the second lesson of this unit. So right here, I got x terms that I can combine, right? So I got negative 1 of these x's and then positive 3 of those x's. When I combine, how many x's would I get? Maybe 2 of them, right there. Now, I don't see any other like terms we can combine, so I'm going to drop the 10 there, which now equals 2x plus 4. And this should look a lot like the two-step equations that we did last time. So from here, We need to isolate those x's, those two x's, by getting rid of that 4. And by getting rid of, I mean making it a 0, or zeroing it out. So it's well, 10 minus 4, that's 6, is going to equal the 2x, we'll just drop it. And then 4 minus 4, that zeroes out just like we wanted it to. Okay, but you see, I did minus 4 on the right side of the equal sign, so I had to do it on the left side as well. Well, this is a one-step equation now because the coefficient of x is not 1. So we'll just divide the coefficient by itself, 2, which creates 1x, and that's a phantom 1 right there. But again, if I do it to one side, I got to do it the other side. 6 divided by 2 is 3. All right. Now remember, a solution to an equation should make the original equation a true statement. So let's just check to make sure that it is true. Okay. So the original equation was 10 equals negative x plus 3x plus 4. But now we think we know the value of x. That should make it true, right? Because we use principles of equality to find it. And we're saying x is 3, right? There in green. Now you don't really have to evaluate this. The calculator will do it for you if you'd like. And I'm putting a question mark over the equal sign to show that I'm not sure if it's true, but we're checking to see if it is true, all right? And we know it should equal 10. The 10 has no operations with it, but these other ones do. So just by the order of operations, and I'm not using a calculator, though you probably should. 3 times 3 is 9, so negative 3 plus 9 is 6, plus 4 is 10. So we get 10 out of that, and 10 does equal 10. That's a true statement. Since it is true, now I know for sure that x does equal 3. Now, some of you guys, just kind of what we saw last time, if you would prefer to see it as x equals 3 like this, that's fine. It's exactly the same thing, okay? So here's number 3. This one works pretty much the same way. Now, we should ask, what are the coefficients in this problem, number 3? And you should know right away that the coefficient of 2x is 2. And the coefficient of that minus x is negative 1 right there. So if you need to see that phantom 1, feel free to do it. So those are like terms which we can then combine. Now you may have noticed on those last problems that we showed that you can't combine like terms on opposite sides of the equal sign unless you use principles of equality. Alright, so even though the 4 and the negative 8 on this one are like terms, we can't combine them because they're across from each other on the equal sign there, okay? So I got 2x minus 1x, that would give me, well, 1x right there. So drop the plus 4, or positive 4, and also drop the negative 8 right there. So finally, to solve this one, we'd subtract 4 from both sides. To zero that out, we'll drop the 1x. I'm going to make that a phantom 1 though. So x now equals negative 8 minus 4, which is negative 12. Okay? So again, I'll show the work on this, but after that, we're going to be using the calculator to check. So it's 2x minus x plus 4. This should equal 8, at least if it's a true statement. So I'm going to be replacing the x's with negative 12 on this, because that's the value of x that we found. And we can evaluate this from this point. So 2 times negative 12 is negative 24. That'd be plus 12 right there, which comes out as negative 12. Oh. Yeah, so make sure when you check that you actually copy it down right there, because that would have been disastrous. That should have been a negative 8 right there, because then it's going to come out as negative 8 there. So negative 12 plus 4 is negative 8. Now it's true. So now we know that x equals negative 12 is the actual solution to that equation. It makes it a true statement. Now, of course, we've only seen combining like terms, but we'll expect to see some distribution in these as well. So number 4, 10 equals negative 2x minus 3 plus 4x plus 5. And again, the first thing we should look to do is to perform any distribution. And that's kind of an order of operations theme. Because when we combine like terms, that's only with addition and subtraction. You can multiply unlike terms, no problem. Which is why distribution is multiplication. And it has to come before combining like terms. But again, on this one, there is no distribution, so no problem. Then I need to look for any like terms that I can combine. So on the left side of the equal sign, we got the 10. All right, well, nothing to combine with the 10. But on the right side of the equal sign, we got 4 terms. Particularly this negative 2x here and this 4x. Those are x terms. So I should be able to combine these, negative 2x's and a positive 4x's, combines to give us positive 2x's. But in addition to these, we got this negative 3 here and this positive 5 right there. Okay, and those are constants, so I should be able to combine these also. Negative 3 combined with 5 would give us positive 2. And remember, we're showing that positive as a plus sign between the 2x and the 2, just to show that they are different terms, and they're not like terms, so we cannot combine those, right? The 10, yeah, we're just going to drop that. So right now, we had started with 5 terms, but we've simplified it into 3 terms. Okay, so I got 10 equals 2x plus 2. So again, distribution, combine like terms, and now we look to isolate those x's. And we do this with the principles of equality. Particularly this one, we're looking to get rid of that plus 2. We want to zero that out. So subtract 2 from both sides. Okay, and that will make 2 minus 2, that becomes a 0, just like we want. 10 minus 2 is 8. This is going to equal 2x that we're going to drop, because it didn't have any like terms to combine with. Now, we want the coefficient of x to be 1, so divide both sides by the coefficient, because anything divided by itself is 1. And then we show it as a phantom 1. 1x, 8 divided by 2 is 4. So that's pretty good, and that was some good work right there. But again, let's show the work and check this one, okay? So it's the original equation, 10 equals negative 2x minus 3 plus 4x plus 5. But we think the x value is 4, so I'm going to look at those two x values and replace them with 4. And then we'll evaluate the right side of the equation, just to make sure it's equal to 10, right? So we get 10 equals, does it equal this? So I got a question mark right there. So I'm going to my calculator, okay? Yeah, negative 2 times 4 minus 3 plus 4 times 4 plus 5. And when I push enter on my calculator, it should be 10. It is. That's pretty nice. 10 does equal 10. That's true. Since it is true, now we know for sure that x does actually equal 4. All right, when we see a fraction like this one, the best thing we can do is get rid of that, well, the fraction part of that, okay? What I mean by that is the division. So that denominator 4, got to get rid of it. Now that's fourth parts. So if I wanted a whole part, I would multiply that by 4. Just remember, if you do it to one side, you have to do it to the other side, okay? So what this does is you have 4 times divided by 4, and the inverse operation is going to cancel out that denominator right there, okay? So you're left with the numerator, which was x minus 1, which now equals 6 times 4, which is 24. Well, that's pretty good, because now we got a one-stepper. Just add 1 to both sides. Okay? So that's going to zero that out, and we get x equals 25. Now again, the calculator will tell us, because we can use the n over d button on this, right? So n over d, I type in, instead of x minus 1, it's 25 minus 1. Then I go to the denominator, I push 4, and then I push enter, and it gives me 6, so that's a true statement. And now I know that x equals 25 is the actual solution to this equation. And we love fractions so much. Okay, so x over 2 plus 1/4 equals 7/4. Need to isolate those x's right there. And we'll do that by zeroing out the 1/4. How do we do that? Just subtract it from both sides. Okay, and that's our principle of equality. That zeroes that out. I'm going to drop the x over 2, which now equals 7/4 minus 1/4. It already has a common denominator. Now if you did that by hand, you'd get 6/4. But that would simplify into 3 halves, which your calculator would have given you pretty quick on that, okay? Now from here, that's x divided by 2, but I don't want divided by 2, okay? I want just 1x. So that's half of an x, so if I give it 2 parts, then it cancels out. It'll give me a full x right there. But just remember, if you do it to one side, you got to do the other side, and those two denominators, the 2 denominator there in red, cancels out as well. So you just end up with x equals 3. Now just to make sure, right? Because we do need to check. I'm just not going to show the work. I'm going to do it on the calculator. I got 3 over 2 because it used to be x over 2, but I replaced the x with 3. And I push plus 1/4. And when I push enter, I should get 7/4, which I do. So now I know for sure that x equals 3. Yep, so here's our first distribution, and there's a couple ways to deal with this. We'll see if we can find another one, but just straight distribution, right? So that'd be 1/3 times 2 x's. That'd be 2/3 of an x. And then 1/3 times -4, that'd be -4/3. And you can put that in the calculator if you need to check it. Of course, this is going to equal the -6 right there. You're just going to drop that one. Now right here we got fractions, no problem, because we can use calculators on this to do these calculations. You could do it in your head or by hand if you'd like, but I like the calculator. And we want to isolate the x's by getting rid of that -4/3. Just add 4/3 to both sides. Right, because whatever you do to one side, you got to do to the other side. So that will zero out the -4/3 there. I'll still drop the 2/3 x, which equals now, I got -6 plus 4/3, so again, I go to the calculator, -6 plus 4/3, and calculator shows me -14/3. Of course, again, you could combine those by hand if you found like terms, or common denominators, but the calculator is a little bit faster on that stuff. Next up, I don't want 2/3 of an x. I would really like just a 1x. So I'm going to take that 2/3 and make it a 1 by dividing it by itself. But again, if I do it to one side, I must do it to the other side as well. So that's going to be a 1x right there, phantom 1. So I got -14/3, and that's divided by 2/3 in my calculator, which shows -7. All right. So I got x is -7, but let's just check. Okay, I'm going to check to make sure it gives us a true statement. So I got 1/3, and I'm using that n over d button, and even the parentheses. So I got 2 times -7 in the parentheses minus 4. I close my parentheses and push enter, and I get -6. So that shows it's a true statement, and I can box it in with at least a lot of confidence there. All right, for number 8, we again, no distribution. I don't even see any like terms to combine on this, so we got to get rid of that plus 4. So yeah, I'd be looking to subtract 4 from both sides on this one to zero out that 4. So we'll drop the 2x over 3. And if you wanted to write that as 2/3 of an x, that's fine as well. Now 14/3 minus 4, you can do the work on your own, but I'm going to put this in the calculator. 14/3 minus 4, bam, I get 2/3. So these combine to give us 2/3. And, well, the denominators are the same, which is pretty nice. In fact, you may see the relationship between 2/3 and 2/3, but I'm going to go through the process on this one, okay, using principles of equality. The first thing I would want to do is get rid of that 3 denominator in black. So to do that, I would have to multiply both sides by 3. Okay, that's principle of equality. Now, again, it just shows that both denominators cancel out, and we end up with 2x equals 2 now. And then we'd say, well, divide both sides by the coefficient, which is 2. That becomes a phantom 1, 1x, and 2 divided by 2 is 1. Okay. Now again, you should check. So 2 times 1, that's 2. 2/3 plus 4. I'm going to go to my calculator for that. All right. 2/3 plus 4. Boom, 14/3. Which is what it did equal. So it checks off. And now I know for sure that x equals 1 is the solution. It makes the original equation a true statement. Now you could clear the fractions, by the way, but I don't really see the need for that. Plus it causes a lot of problems, just small errors. Not big ones, but small ones. So let's just stick with the fractions on these, okay? So like this one, I want to isolate my 3x, so I don't want that plus 1/5 with it. And this one's nice because they are common denominators already. So I'm going to zero it out. So I'm going to subtract 1/5. But again, if I do it to one side, I must do it to the other side. So I got 4/5 minus 1/5. That'd be 3/5. Which is going to equal, we'll drop this 3x there. And then, of course, our 1/5 minus 1/5 is 0. So I got 3/5 now equals 3. Well, the last thing we got to do is divide both sides by 3 in order to make that coefficient of x a 1. So I got 3/5 divided by 3. Just type that into the calculator. Give you 1/5. And again, if you're doing that by hand, you may have gotten 3/15, but it would have been simplifiable into 1/5. Let's just check, right? So I got 3x plus 1/5, but instead of x, I got 1/5. So 3 times 1/5, and then plus 1/5. Okay. Plus 1/5 equals 4/5. So that's a true statement. And now when I box this in, I feel very confident about it, okay? Because we checked our work. All right, problems like this one. And I think we saw problems like this on the, well, kind of, in the proportions unit. This is a proportion. It's really 3/1. Not that that matters right now. Because really the only thing I'd want to do, just to start out with, is get rid of that 3 denominator on the left. And how do I do that? Well, it's divide by 3, so if I can use just the inverse operation on that, by multiplying by 3, it'll cancel out that denominator. Okay? By cancel out, I mean it becomes a phantom 1. So over here we get 3 times 3, which is old 9er. And then we still have that numerator, negative 2x minus 5. Okay, now this becomes a two-step equation for us, which we've seen before. So I'd say isolate your x's by adding 5 to both sides and zeroing out that negative 5. Drop your negative 2x there. And this equals 9 plus 5, 14. And then divide both sides by the coefficient of negative 2. To make that a coefficient of 1, phantom 1. And 14 divided by negative 2 is negative 7. So again, I'm going back to check on this, right? So I got, and I am using the n over d button on this one. So I can see the fraction on the calculator. I got negative 2 times negative 7 minus 5. And then I go to the denominator and just push 3. When I push enter, I get 3. And again, now I know for sure that x equals negative 7 is the solution. All right, now number 11, this one has distribution. So yeah, let's go ahead and distribute, okay? No problem. Distribute, this is negative 2 times x, which would be negative 2 groups of x. And negative 2 groups of 1 would be negative 2 right there. Still equals 8, which we dropped right here. Well, this looks a lot more familiar now that we've done the distribution. And so it's a two-step equation. Let's isolate our x's by getting rid of that negative 2 by adding 2. But if I do it to one side, I must do it to the other side as well to zero that out. So I'm going to drop my negative 2x, which now equals 8 plus 2 is 10. Finally, we'll divide both sides by negative 2, which makes x equal negative 5. So let's just check, right? And we don't really need a calculator for this one because the calculation is pretty easy. Negative 5 plus 1, that's negative 4. Negative 4 times the negative 2 is positive 8. So that checks off. So on number 12, we see some distribution right here with the negative 3. And we do need to distribute it into the parentheses. Okay? Now remember, distribution is multiplication. So it's really negative 3 times. You can show the 1x if you'd like. The phantom 1 right there. So that's negative 3 groups of 1x, which is negative 3x's. And also you got negative 3 groups of negative 4. Now that's negative 3 times negative 4, which is positive 12. Now you may ask, well, why is it negative 4? It's because the term itself is considered negative 4, because it's minus 4. Alright? So don't forget that piece. So we got all the distribution done. It's 13 equals negative 3x plus 12 minus 8. And that takes care of the distribution. Well, now that we've got it distributed, we should look for any like terms to combine. And there is. There's this 12 and negative 8. 12 and negative 8 combine to give us positive 4. So the new equation now, 13 equals negative 3x plus 4. And we can see all 3 different terms. This one's nice because they're all 3 different colors. That's fine. But I want to isolate my x's, which means I don't want that plus 4 with the x's. So subtract 4 from both sides. So 13 minus 4, boom, 9er, is going to equal the negative 3x. We'll drop that. And 4 minus 4, that zeroes out just like we wanted it to. Well, we'll divide both sides by the coefficient of negative 3 to make the coefficient of x a 1. Phantom 1, x equals negative 3. But again, I'm using my calculator to check. Actually, this one shouldn't be too bad. So I'd say over here, negative 3 minus 4, that's negative 7. Negative 7 times negative 3 is 21. 21 minus 8 is 13. There we go. So we checked it off, even though we didn't use a calculator, and that's okay. And I know now that x equals negative 3 is the solution to this equation. So these equations are getting bigger, but I don't know that they're getting more difficult, right? It's just more steps, I guess. So for this one, still got some distribution, and we should always look to distribute first, okay? And that does come out to kind of an order of operations kind of thing. So I'm looking at my 2. I need to distribute that into my parentheses. That's 2 groups of 3a, which would be positive 6a's. And then it's 2 groups of negative 1, which is negative 2. Now again, that reads as minus 2, 6a minus 2. But we also have the other values in there. We got this 5 and this equals 15. All right? So that's distribution, and I think this is our first one where we see like terms that we can combine. Maybe it was the second one. And there are like terms that we can combine. Specifically the 5 and negative 2. 5 and negative 2 combines to give us 3. Now I still got the positive 6a, and this still equals the 15. Alright, so that just simplifies the equation, which hopefully will make it a little bit easier to solve. Now I got to isolate my a's in this case by getting rid of that positive 3. So I'm going to zero it out by subtracting 3 from both sides. To zero that out, I'm going to drop my 6a there, which is going to equal 15 minus 3 is 12. Oh, that's going to work out very nice, because our last step on this one is to divide both sides by the coefficient 6 to make the coefficient of a 1. So it looks like a is 2, but let's just check again, right? And again, we can do this one without a calculator, because this one should turn out pretty easy. So 3 times 2 first, that's 6 minus 1. That's 5. 5 times 2 is 10. So you got 5 plus 10 is 15. So that checks off. That is a true statement. And again, we can box that in with some confidence. That's where we run into the order of operations, right? So if you did 5 plus 2 first, and this does happen, it doesn't happen often on tests and quizzes, but it happens often enough that, yeah, we should address this. Some students, they say, well, I'm going to do 5 plus 2 first, right? That's 7. But that's out of order because distribution is multiplication. You have to do the multiplication first. And yeah, you could say the parentheses first even, but it's the multiplication of the distribution. You have to do that first before you look at that addition part. So here we go. We got 1/2 of 2x and 4 equals negative 8. So yeah, we got some distribution just with the parentheses right there. So 1/2 groups of 2 t's would be 1t, 1/2 times 2. And then 1/2 groups of 4 would be positive 2. And yeah, try not to get the t and the plus 2 mixed up there. Now the coefficient of t is 1, so if you wanted to change it into a phantom 1, that's okay. And this equals this negative 8 right here. So to isolate that t, let's get rid of the plus 2 by zeroing it out. So subtract 2 from both sides to zero that out. Drop your t, so this is going to give us the answer right away, because coefficient of t is already a phantom 1. And negative 8 minus 2 is negative 10. Oh, I should check before I box it in. Let's check. 2 times negative 10 is negative 20, plus 4 is negative 16. 1/2 of negative 16 is negative 8, so it does check off. I know this one's different, but you guys try this one out, okay? See if you can do this one. We'll give you 1 minute. 1 minute, go. Now, there's not any one specific right way to do this. I'd say there's at least 3 different common ways that people do this problem, all right? But here's what I would do on this one, and again, it's not required that you do it my way, all right? Is first off, I got this x minus 2 over 5. I would split this up and make it x over 5 minus 2 over 5, okay? Because that's a common denominator right there, which can be split up. Okay, so I'm manipulating this to do what I want it to do, which hopefully will make it easier for me. Alright, so this is what I end up with as an equation, and we do have the 2 like terms that we can combine, right? Now that's 1/3 of an x plus 1/5 of an x. Now if you were to add these together, you need common denominators. I just use a calculator. 1/3 plus 1/5 shows me as 8/15 of an x. I still got the minus 2/5, and this equals 6. Now to isolate these x's, the 8/15 x, I need to get zero out that negative 2/5. So add 2/5 to both sides. And again, I would just go with the calculator to add that 6 and 2/5. So I got 8/15 of an x, which now equals, I guess that'd be 32/5. Right there. And then, I don't want 8/15 of an x, I want a 1x, right? So I'd say, well, divide this by 8/15. And also divide this by 8/15. And let's see, what do we get on that? 4 and 3 is 12. Looks like x equals 12. Let's just check. I'm going to use my calculator to check. 32 over 5 divided by 8 over 15. It does equal 12. So let's just check in the calculator, right? So I got 12 over 3. Now I know that's 4. Plus that'd be 12 minus 2 is 10 over 5. That's 2. 4 plus 2 is 6. So x equals 12 is the solution to this equation. Now another common method for this one is finding common denominators. But again, I like to avoid that method just because it's full of small mistakes. So if you're looking to cancel out the fractions, which you can do, all right, then you need all of the terms, every single term in the equation to have the same denominator. That's the only way to do it. But that means you're going to be scaling these fractions as well. Okay. Now, what this means, what I just said, is that we have to acknowledge that the 6 has a denominator of 1 right there. It has a denominator, it just didn't see it. It's one of those phantom 1s. So we got denominators of 3, 5, and 1. We need the same denominator in order for us to just kind of ignore the denominators, all right? So 3, 5, and 1, I'd say the lowest common multiple between these three numbers is 15. Okay, so that means that the first fraction, I need it to be in 15ths. Same with the next one. And even the 6, I need this to be in 15ths. Okay? Now this is scaling the fraction, so I'd say, well, what do you multiply 3 by to get 15? Well, you multiply it by 5. But if you do it to the denominator, you got to do it to the numerator in order to maintain equality in the fraction. So now it's 5x over 15. And yeah, that's plus. And then this x minus 2, you're going to have to multiply that by 3 right there. So this ends up, well, I'll show the parentheses like this. Okay, so that scales that fraction up. It looks different, but it has exactly the same value. And then 1, you'd have to multiply that by 15, so 6 also by 15. That's going to be 90/15ths. Now here's the beauty of finding common denominators, but again, it's fraught with peril because a lot of students, not a lot, but a few students end up making small mistakes on this one. Sometimes they forget that 6 has a denominator of 1. Sometimes it's just scaled incorrectly, just small errors. But once you get it like this, you get to ignore the fractions because all the calculations would be comparing the same size pieces. So it really comes out to 5x plus 3 parentheses x minus 2 equals 90. And we can see from this that you're going to get the same answer there. So 3x minus 6 is going to be 5x positive 3x equals 90. Combine your like terms there. That's 8x right there. Minus 6 equals 90. Add 6 to both sides to make that 96. And we'll drop the 8x, just divide by 8, and you see x is 12 again. Same answer, different method, but this cancels out the fractions. So we need to start with that distribution of the negative 3. And yes, it is a negative 3 because it's going to take that operation subtraction as its sign. So it's negative 3 groups of x, which would be negative 3 x's. And then negative 3 groups of negative 2, that's positive 6 right there. All right. Now, generally speaking, especially at this point where we haven't had a lot of practice with these types, that's where the first mistake is made. Okay. So if you made that mistake, don't worry about it. If you didn't, then that's good too. Okay. Now that we've done the distribution, we have some like terms to combine, right? 5 and positive 6. It's going to combine to give us positive 11. So now it's 14 equals 11 minus 3x. Well, we don't want that purple 11 with the negative 3x. We want it isolated, the x's. So let's zero that out by subtracting 11 from both sides. 14 minus 11 is 3. 11 minus 11, that zeroes out just like we wanted. And we'll drop this negative 3x. Finally, we'll just divide both sides by the coefficient of negative 3 to make that a phantom 1x. And 3 divided by 3 is negative 1. So again, this becomes pretty easy to check. I got negative 1 minus 2, which is negative 3. Negative 3 times negative 3 is 9. 9 and 5 is 14. Right there. So that checks off. I think this is our first one. We're seeing x's on both sides of the equal sign. That's okay. No problem. Well, we don't want x's on both sides of the equal sign, right? We know that in the end, we just want our answer to be x equals something, not x equals x and something else. Yeah, that's a positive 2x right there. All right, so 4x equals 2x plus 12. But yeah, remember, we're trying to get this to be x equals something, okay? And this comes with manipulating. You guys got to take control and use the principles of equality that we have, and also distribution and combining like terms, in order to manipulate this down so that it's just x equals some number. But right now it's 4x equals 2x plus 12. So I only want x's on one side of the equal sign, okay? So using principles of equality, you can do it to x's, you can do it to numbers, it doesn't matter. Here's what I mean by that. Is for me, I would say, I want all my x's on the left side of the equal sign. That would be me. And then I would want all my numbers on the right side of the equal sign. That would be good. But the problem is, you see this 2x right here. That's on the number side of things, but it's an x term. So I got to zero that out. So I'm gonna subtract 2x from both sides there, which is going to actually zero that out. 2x minus, sorry, that should have been 2x. Minus 2x is 0. That zeroes out. 4x minus 2x there is 2x, which now equals, and we'll drop this 12 right here. Well, that looks a lot better, because now all the x's are on the left side of the equal sign. Simply divide both sides by the coefficient of 2 to make that 1x. 12 divided by 2 is 6. Now, of course, you could check, right? 4 times 6 is 24. 2 times 6 is 12. Plus 12 is 24. So 24 equals 24 is a true statement, and therefore x equals 6 is the solution to this equation. So keep this in mind looking at the future problems. You have to have the x's on one side and all the numbers on the other side. But always do distribution and combining like terms first, which is good, because a lot of the problems we're going to see in the future have x's on both sides. All right, so your worksheet shows this. That's okay. 5x plus 3 equals x plus 27. Now, again, we're still seeing x's on both sides, so that's not a problem. When you see x's on both sides, though, you have to make kind of a quick choice. And yeah, if there was distribution, we'd have to do that first, or even combining like terms. But you can do this at any stage of the process, okay? And what I'm talking about is deciding which side you want the x's on and which side you want the numbers on. Because in the end, we're going to end up with x equals some number, right? And we don't know what number it's going to be. But that's what we end up with, which means that you have a side for the x's, and I'm going to say it's going to be on the left. And that's generally where most students put it. And then numbers on the right. And yes, that's a number symbol, not a hashtag for my generation, okay? So, since I've got x's on the left and numbers on the right, here's why this is important, okay? Because I know I'm going to use a principle of equality here. So whatever I do to one side, I got to do to the other side. Now, since I've got x's on the left, the 5x is okay. That's on the correct side of the equal sign. But the plus 3 does not have an x. It's not an x term. It's only a constant, so I need to zero that out. Okay, so I'm going to subtract 3 from both sides. Now, just be careful, right? You guys saw that I put the minus 3 under the 27. You can't put the minus 3 under the x because they're not like terms. Okay, so we cannot do that. Don't put it there. They're not like terms. You got to combine it with a like term, like 27, another constant. Well, what does this do? Well, it gives us 5x. We'll drop that because we didn't operate on it. The 3 minus 3 zeros out. Is going to equal the x also will drop. Then we got 27 minus 3, which is a positive 24. Okay? So right there, we got rid of a constant on the x side of things. But if you continue to scan this, and I usually always scan from left to right, right? Because I started with 5x and I went to positive 3. Now the new equation, 5x equals x plus 24, I'm still scanning from left to right. And we got this, and you can show it as a 1x if you'd like. But it's on the number side of things, okay? Since it's on the wrong side, incorrect side, I need to zero that out. Okay, so that's just subtract 1x. But again, if you do it to one side, you must do it to the other side as well. So 5x minus 1x is 4x. And then this is going to equal, and again we see that 1x minus 1x, that does zero out. We'll drop the 24 there. So 4x equals 24. And yeah, you know, some of you guys may have had the answer by this time. In fact, at this point, some students don't even show this last step. I mean, I still recommend that you do. But some students are like, I know I can do this in my head. Divide both sides by the coefficient of 4. 24 divided by 4, yeah, it's 6, right? And again, you can check. You can put in the calculator if you'd like. I don't know that it's necessary on this one. Yeah, 6 times 5 is 30 plus 3 is 33. And then 6 plus 27 is 33. So that checks off. And I know for sure that x equals 6. So here's our next one. Negative 4x plus 6 equals 3x minus 36. All right. So again, just for me, now I'm going to put the x's on the left and the numbers on the right. But let's say that you were like, dude, I'm going to put my x's on the right and numbers on the left. No problem. You'll still get the same answer, it's just going to look a little different, okay? And I'll show that at the end. So in this case, just kind of scanning these terms, right? Negative 4x, that's on the correct side of the equal sign. It's got an x with it. But this positive 6, and so I'm scanning from left to right, positive 6 does not have an x. So I need to zero that out by subtracting 6 from both sides. Now you'll notice in purple here that I put minus 6 below the negative 36. That's because they are like terms. If you did 3x minus 6, they're not like terms. You couldn't even combine those. Okay? So I have to put the minus 6 below the like term on the right side. But again, if I did it one side, I got to do it the other side. So that does zero that out. And I'll drop the negative 4x there, which now equals, I'm going to drop the 3x as well. And negative 36 minus 6 is negative 42. So continuing the scan, negative 4x, we already know that's on the correct side. But the 3x is on the number side of things, but it has an x with it. So it's an x term. We got to zero that out as well. So subtract 3x, but if you do it to one side, you got to do the other side, guys. So I will zero that out. Negative 4x minus 3x is negative 7x. This is going to equal, and we're going to drop the negative 42 there. So a one-stepper now. We'll divide both sides by negative 7 to make the coefficient a 1. So x now equals 6. Now we're going to check though. We're going to check. Negative 4 times 6 is negative 24 plus 6. That'd be negative 18. So this is negative 18. 3 times 6 is 18. Minus 36 is negative 18. So that produces a true statement when x equals 6. So there's our solution. Whether we see decimals or not, the principles of equality still apply. Okay, even if it were fractions, just like we've seen. You can add or subtract or multiply or divide fractions on both sides of the equal sign, but you can do the same thing with decimals. Okay. Now, like I said, just generally speaking, most students prefer to put the x on the left, numbers on the right. You don't have to though. Okay. If you'd prefer to put the x's on the right, which later on, I don't know, it's not really important, but you can. Okay. And it may become more convenient, but for now, it doesn't matter. Okay. So I'm going to keep the x's on the left and the numbers on the right. We may do an example where we switch it though here in a second. Now this one doesn't require any distribution. It doesn't require any combining like terms. So I'm going straight to my principles of equality so I can isolate my x's. So the 0.7x, again, I'm scanning from left to right. That's on the correct side. It's on the x side of the equal sign. But that negative 0.6 is on the wrong side. It's a constant. So I'm going to have to zero it out by adding 0.6. But if I do it there, I must do it over here as well. And again, I'm pointing this out. I'm putting it under the other constant because they are like terms. You can't combine unlike terms. So that's going to zero that out. We get 0.7x equals, we'll drop the negative 0.2x. And negative 0.42 plus 0.6 equals a positive 0.18. Right there. And I don't know if the zero helps right there, but maybe it does. So that's a negative 0.42 plus 0.60. And that'd be positive 0.18. Okay? Yeah. So again, we scan this new equation, and I've got that negative 0.2x on the wrong side. It's on the number side of things. So I'm going to have to add 0.2x to zero that out. But if I do it to one side, I got to do it the other side. And this then becomes 0.9x, which now equals, and that zeroed out just like we wanted, 0.18. Oh, very nice. Because now, when I divide both sides by 0.9, that'll become a phantom 1 right there. But we get x equals, I'm having a brain fart. I know that should be easy, but I'm going to do it. 0.18 divided by 0.9. I'm using my calculator. 0.2. 0.2 on that one. But let's check, right? So I got 0.7 times 0.2, and yeah, I'm not good enough with decimals to do it in my head, or at least it's too early to do it. And push enter, I get negative 0.46 on my calculator. Let's do the right side, negative 0.2x, but now x is 0.2, so times 0.2 minus 0.42 equals negative 0.46. So that checks off. It still gives us a true statement. All right, 23. Now this is, hopefully this looks familiar slightly. This is a proportion, which we have seen before. And we're going to solve this proportion with cross multiplication, just like we've done before. All right. So the red cross shows two groups of x minus 1. Now it's equal to the other cross, which I have in purple. That's four groups of x and 3. So this becomes our new equation after the cross multiplication. We'll distribute the 2 and the 4 separately. So that'd be two groups of x, and two groups of negative 1 is negative 2. This will equal four groups of x and four groups of 3, which is positive 12. Now again, just going back, I'm going to put my x's on the left and the numbers on the right, no problem. 2x is good, but that minus 2 or the negative 2 is on the wrong side. I cross-multiplied in the beginning there so that we could get rid of the fractions. That way it looks a little bit more, I don't know, familiar. Now, did you have to do that? No. You could have used the common denominator thing. But generally speaking, most students prefer to see this with cross-multiplication, which is why I'm using cross-multiplication now. All right, so the negative 2, I got to zero that out. So I'm going to add 2 to both sides there. And again, that I'm putting that orange plus 2 on the right underneath the positive 12 in green because they are like terms. So we'll drop the 2x now, which equals 4x. And 12 plus 2 is positive 14. But now we got that 4x in green on the number side of things. Let's zero that out by subtracting 4x from both sides. So now I got negative 2x equals that positive 14. And finally, divide both sides by negative 2 to make this x equals negative 7. Let's just check, right? So negative 7 plus 3 on the left side of the equal sign, that's negative 4. Negative 4 divided by 2 is negative 2. So we should get the same thing on the right side. That's negative 7 minus 1 is negative 8. Divided by 4 is negative 2. So negative 2 equals negative 2. It's a true statement. Therefore, we know x equals negative 7 is the solution. So this is a proportion because we have a fraction that equals a fraction. It's just kind of set up different than what we saw perhaps in the proportions unit. So, but since it is a proportion, we can use cross simplification to solve it. Okay, so one cross will equal the other cross, and this is 5 groups of x minus 3 right there. And it's going to equal the other cross, which is 3 groups of 2x plus 4. Now, you didn't have to do it like this. You could have worked with fractions, but generally speaking, most people prefer to get rid of the fractions because fractions destroy lives, some lives, lots of lives actually. And from here, we're looking to distribute because we got some parentheses right there. So that's 5 groups of x is 5x. 5 groups of negative 3 is negative 15. And this will equal the other distribution. 3 groups of 2x is 6x's. And 3 groups of 4 is positive 12. Now, we're seeing an equation like we've seen before. And again, I would say, well, let's put the x's on the left and the numbers on the right. Not that you'd have to. But if this is the case, then I'd say, well, that negative 15 is on the wrong side. Let's zero it out. So add 15 to both sides. To zero that out, just like we want, we'll drop the 5x, which now equals 6x. We'll drop. And 12 plus 15 is a positive 27. Next, I'll get rid of the 6x because it's on the wrong side. So minus 6x from both sides. That zeroes that out, and I get negative 1x there. Equals is 27 will drop. And finally, we'll divide both sides by the coefficient of negative 1 to make that x equals negative 27. Okay? Let's just check. Let's just check on the original equation, right? So negative 27 minus 3 is negative 30. Divided by 3 is negative 10. Okay, that's pretty easy. 2 times negative 27 would be negative 54. Plus 4 would be negative 50. Divided by 5 is negative 10. So that checks off as well. And we can box that in with some confidence on that. So 29, I don't see any distribution. That's the first thing we should do, is distribution. So since there's no distribution, I would look and see, is there any like terms that I can combine? And there is, right? We got this 7x's and this negative 4x's. That'd be 3x's right there. And then on the right side of the equal sign, I've got a 7 and a 4, which combine to be positive 11. That's a constant. Now I still got this plus 2 equals 11. And then we got this positive 2x there. So we started with 6 terms. We narrowed it down into 4 terms by combining like terms. That's nice. Now, like I said, I'm going to put the x's on the left, numbers on the right. Not that you have to. But that plus 2 should have an x term, but it doesn't, so I'm going to have to zero it out. Subtract 2 from both sides. So we'll drop the 3x. 2 minus 2 zeros out. Equals 11 minus 2, which is a little 9er. Then we'll drop the positive 2x. So now, scanning this new equation, the positive 2x is on the number side of things, but it shouldn't be. It should be on the x side of things, so zero that out. Subtract 2x from both sides, which is going to make that 1x equals, and yeah, we'll drop the 9er. That zeroes out. Now that's 1x. I'm just going to make it a phantom 1 and call it a day. Let's just check. 7 times 9 is 63, plus 2 is 65. Oh, I should probably do this one. 65 minus 4 times old 9 is 36. I get 29. And then 7 plus 2 times 9 is 18, plus 4 is also 29. So that checks off that x equals 9 is the solution. So on number 30, again, we have some distribution that we should start with. Okay. And we got 2 sets of distribution right here. So that's 4 groups of 1, which is 4. 4 groups of negative 1x, that'd be negative 4x's. And on the right side, it's negative 2 groups of 1x, that'd be negative 2x's. And 2 groups of positive 1 is negative 2. So the new equation after distribution, 4 minus 4x plus 3x equals negative 2x minus 2. Well, now that we've done distribution, always look to see if there's any like terms to combine to simplify the equation. And yeah, I got these two x terms right here, negative 4x plus 3x. That's negative 1x. So now I got 4 minus 1x equals negative 2x minus 2. And at this point, since we've simplified it with distribution and combining like terms, we'd have to see which side we want the x's on. And I'm just going to choose, again, x's on the left, numbers on the right. So that positive 4 on the left in red, it needs to go. It needs to be zeroed out. So subtract 4 from both sides. And again, make sure you're combining that with like terms. That'll zero that out. You got negative 1x equals this negative 2x. And negative 2 minus 4 is negative 6 right there. But now that negative 2x in red is on the wrong side, so I need to zero that out. So add 2x to both sides. To make that, 1x, so I'm going to make that a phantom 1. And the negative 2x and the positive 2x zero out, and we'll just drop this negative 6. So I get x is negative 6. I'll use my calculator for this one. It's kind of a long expression there. 4 parentheses, 1 minus negative 6. And the minus and negative buttons are different. Plus 3 times negative 6. And when I push equals, I got 10. And on the right side, negative 2 parentheses, x, but it's negative 6 now plus 1. Close parentheses equals 10. So I see that it gives me a true statement when I replace x with negative 6. Therefore, it is the solution. So yeah, there's definitely some distribution on this one. We need to distribute that 1/4 into the parentheses. Now that's 1/4, that's all multiplication with distribution. So 1/4 times 12x, that's going to be 3x's. And then 1/4 times positive 16 is positive 4. But we also have this distribution on the right side, right? So and that's a negative 3 multiplied, that's we're distributing it in parentheses. Because it's going to take that minus sign as its sign. Okay? So that's negative 3 times 1x, which is negative 3x's. And negative 3 times negative 2 is positive 6. So our new equation now, 3x plus 4 equals 10 minus 3x plus 6. So after distribution, I look for any like terms to combine on that. Yeah, so like terms, I got the 10 and 6 right there, which is going to combine to be 16. So this now narrows our equation down just a little bit. 3x plus 4 equals 16. And again, that's a negative 3x term right there, so keep it negative. Next up, again, I'm going to put the x's on the left, numbers on the right. Well, you know what, I'm going to switch it up just to show we can. What the heck. There's numbers on the left and then x's on the right there. That's an x. So now that 3x on the left, that 3x is on the wrong side for me now, so I'm going to zero it out. So subtract 3x from both sides. And again, your answer should be the same either way, so that's going to be zeroed out there. We'll drop the 4, which equals the 16, which will drop. And negative 3x minus 3x is negative 6x. But now the 16 is on the x side of things, so let's subtract 16 from both sides. Which is going to make that negative 12. 4 minus 16 equals, and yeah, this zeroed out. So we'll drop the negative 6x there. And then finally, we'll divide both sides by negative 6 to make the coefficient of x a 1. So that's x equals 2. Now that's because I put the x's on the right. If you put the x's on the left, you'd get the same answer. It just looks like this. Okay. So even though it looks different, it's the same exact thing. We need you guys to get used to seeing x's on either side, okay? Because it doesn't matter. It doesn't matter. Same answer, so yeah, I'll put more between that just to clarify. Now let's check though. So I said x is 2, so I'm going to plug this into my calculator exactly like I see it. 1/4 parentheses 12, but instead of x, I'm going to put 2. So at 12 times 2 plus 16, close parentheses, I get 10. On the right side, I got 10 minus 3 parentheses x, but now x is 2 minus 2 close parentheses 10. That's correct. So that confirms that x equals 2 is the solution to to this equation. Either one. All right, if I were to see a problem like this, I would say I got that denominator of 3. I don't like it. I want to get rid of that 3, okay? So that's divide by 3, so to get rid of it, I can just use an inverse operation by multiplying both sides by 3. Now when I say both sides, I'm multiplying the entire right side by 3, so I need to put that in parentheses. But it will cancel out that 3. So you have to determine whether you feel like that makes it more or less easier. You could just break up the fraction into 2 terms if you'd like. And yeah, I'll just do the distribution at this point. So 3 groups of 8 is 24. And 3 groups of negative 3x would be negative 9x's. So there's no like terms to combine, so I'd say keep the x's on the left, numbers on the right, which means that negative 9 has to zero out, so add 9 to both sides to zero that out. So 2x equals 24 plus 9, 33. And then we'll drop this negative 9x there. But the negative 9x is on the wrong side of the equal sign, so zero that out as well. Add 9x to both sides. Oh, it's going to turn out very nice. 2x plus 9x is 11x's. You're going to equal that 33 because the negative 9x and the positive 9x are going to zero out. Divide both sides by the coefficient and we're good. So x equals 3 in this case. Let's just check real quick. So I got 2 times 3 is 6 minus 9 is negative 3 divided by 3 is negative 1. All right, let's check the other side. 3 times 3 is 9. 8 minus 9 is negative 1. So that checks off. And now we know for sure x equals 3 is the solution.